All right. I think we can get started. More people will join along the session, and
Yeah, sure.
I'm sure a lot of people will tune into the recorded one as well. So, yeah, let's get started. Okay. Hello, everyone. Good evening from this side of the world. I am Jannat, and I'm going to be your host for today's session. Welcome to another Titanium Talks AMA. Today, we're thrilled to have with us. Juan Luis Vargas Molina. Pardon me if I pronounced it wrong.
No
But
worries.
yeah, we have Juan from Factron. Just to give you guys a little overview about what the AMA is gonna be and what Factron is. And basically, Factron is a project. Here's the highlight. Okay, so they're funded by Coinbase. That's a pioneering, and Coinbase is pioneering a new approach to blockchain. With its unique proof of usual work consensus. So Factron is basically redefining what's possible by replacing traditional hashing with the integer factorization. Oh my god. Even I'm excited. We'll try to cover the basics and yeah, we'll try to make it easy for our audience not to get way too technical. But yeah, so we'll dive into how Factron works, why it's different, and the impact it could have on the future of security and decentralization. So, Johan, definitely it's an honor to have you with us here today. Thank you so much for joining.
Thank you very much for having me. Something I would like to mention. The name of the project is Factor N, and so we are going to soon be rebranding the project. And this is like one of those silly reasons of like the current name. People usually pronounce it Factron, and it's Factor N. So we will soon be rebranding, and this is like one of the things that we want to address in the project. We want to project a clear message, and that starts with the name, which is like the very first thing that people see. So very soon it will just be Factor, just plain simple and sort of easy to pronounce. And as you well mentioned, the development of the project was funded by Coinbase. We won one of the competitions they had back in 2022. And as for the proof of work, it is very different from traditional proof of work blockchains. We chose a research area in mathematics that has a very difficult problem, and we turn that into the proof of work. And as a matter of fact, that proof of work is what's used in a couple of cryptographic objects to secure websites, to make digital signatures. And so we thought it would be a perfect idea to provide security as well as contribute to research and cryptographic security in the internet. And so yes.
Awesome. All right. Thanks. Firstly, thanks for correcting me, Ivan. And yeah, everyone, we already got an announcement at the start of the session that, the rebranding is coming soon. And yeah, you guys have been around for quite some time. I see. So, okay, let's get started. Before we hop on to the questions, Yuan, we'd like to have a little introduction about yourself. What is your background and how you decided to be a part of Factor N.
Sure. So I am a mathematics major, computer science minor. I graduated in the US. I then went to grad school to get a PhD in math. But 1 year into my program, I got a phone call from the National Security Agency in the US. And they offered me a job. I had applied when I was in undergrad, but they never responded. But 1 year into grad school, they called me and offered me a job. So I left my PhD to go and work at the National Security Agency for 3 or 4 years. And there I learned cryptography. And they have a program called the um, applied mathematics program, which is one of the programs for mathematicians, where essentially you learn cryptography, a lot of it, and in the a lot. You learn a lot of theory, but you apply it sort of every single day. So I have a lot of sort of hands-on experience in the cryptography space. And so I worked there. I graduated from the program, and then after that, I left for the private sector. I was worked as a contractor in a couple of companies doing cryptography work, and then I got into cryptocurrencies, sort of around 2020, 2021, when the Dogecoin meme era sort of began, if you will. And one of the things that I wondered as I began to learn about the technical side of cryptocurrencies is I don't understand. It's like, why hashing? Like, why is hashing the base of the security for all these blockchains? And so I began to wonder, it's like, well, there's sort of a couple of algorithms that could replace that. And then as I dug deeper into why, I learned why. And it's because it is extremely difficult to take a cryptographic algorithm, a traditional cryptographic algorithm, and convert it and package it as a proof of work mechanism for blockchains. And as I tried to do this in several different ways, and I fail at all of them, I got an insight into integer factorization. And so I was like, okay, maybe I could find a way to make this work. And that was when I sent the proposal to Coinbase and sort of everything happened. But my background is of formal mathematics, formal cryptography, a lot into the theory, and then I got a lot into the practice. And I learned at the best place in the world to learn cryptography, which is the NSA in the US. And so that's sort of a little bit of my background.
Well, heads up, everyone. We have a pro today. And yeah, actually, the problem you mentioned now, I never really thought about it before. But now that you mention it, now that I'm, learning more about factor N, so it's interesting. And now even I wonder why was it the way we like why is it the way it is? Why didn't we go for alternatives? So yeah, excited to learn more about it. And yeah, let's connecting to this, let's get started with our first question, which is this question: what makes factor n's proof of useful work unique compared to those traditional proof of work mechanism systems?
So there's a couple of things that make it unique. The first one is it's not hashing, is integer factorization. So it's a completely different problem. Second, it is an active area of research, and as a matter of fact, since 1991, there is something called the RSA challenge, which is a list of integers of greater and greater size that are challenges to be factored. There is a monetary reward for factoring them. I think the last one that was factored was 2007 or 2012. I don't remember well. The reward for them was deprecated around 2010. So they no longer paid to factor them, but for about 20 years they did. I think the highest price that was paid was $20,000. And actually, the world record for integer factorization is as recent as 5 years ago. And Google was involved in that effort, and there were some governments who put money for that research. And so that just gives you an idea of how important integer factorization is in the world's cryptography and for mathematicians. And so, third, and this is for miners, the algorithm is very friendly to CPUs. The algorithm has three steps. Two of those steps are very friendly to CPUs, and one of those steps is friendly to GPUs. And so, in particular, every mining rig, like every mining ASIC, is useless to mine factor n. because what they do is hashing, and this is a completely different problem. And so one of the things about the proof of work for factor n is that you will not be competing with any asics because there are not any for this particular algorithm, and so it levels the playing field quite a bit. The open source software that is used for it is maintained by the France Research Institute, INRIA. And so, in some sense, the best software there is directly funded by the French government, quite literally. And so, our mining pool leverages that software coupled with some other things for the mining pool for the project. And so, it's useful work. It's subject of research today, active research. It levels the playing field because no mining ASICs exist for it. And the one of the true what sort of one of the most useful things it has is that, if you are a company that wants to audit the SSL certificates you have, the signatures you have, the keys that you have for the RSA algorithm, for example, there is no business today on earth that would do proper cryptanalysis to check if you have good keys. And so, one of the things this project does is that it has a service where you could place a reward on an integer so that, the community can have a crack at it, much like the RSA challenge. But instead of having a fixed list, you could add your own number to that list. And so there is that business side of the blockchain. And while you are not trying to audit the keys of some company that place a key on the blockchain, what you could be doing with your software is mining instead. So mining is sort of the refuge for your hardware while you are not auditing keys that were placed into the system.
Got it. Thanks for such a detailed answer, Johan. I'm actually learning a lot of new things today. Well, just to extend this question, um, how does replacing hashing with the integer factorization improve blockchain utility and security? I mean, you kind of touched upon it, but if you'd like to add something.
Well, sure. Well, I'll give you an example. So, the formal cryptographic algorithm that uses integer factorization as a security to protect data is RSA. That is the name of the algorithm. All banks in the US use it. In fact, the banking sector is where this type of algorithm is the most prevalent today, which is kind of an interesting thing that, banks to protect all of their money and communications online use this one algorithm. And so this gives you an idea of the importance and how reliable the RSA algorithm is and has been for the last 30, 40 years to protect information online. And so this is why it is an active area of research. And so one of the things that happens is that the difficulty level of the blockchain increases in direct proportion to how good the world gets at factorization. And so, in particular, the difficulty level of the blockchain is a live barometer of how good we have gotten at factoring. And so, what that does is that it informs banks, it informs institutions that use RSA to protect their data, how safe their parameters are. Because, for example, today the recommended parameters are 2048 digits. The blockchain right now is around 460 digits for the mining part, but we have factored integers today that go up to 700 digits. And so the barometer of how good we are getting at factoring is reflected on the blockchain, directly on the blockchain, because there is an incentive that if you discover an improvement in the algorithm, if you discover some theoretical improvement on the algorithm, all of that can be monetized by putting it into mining the blockchain, and also by auditing RSA keys that are placed on the project. And so this gives you sort of a direct and clear line between what the project does and what the utility in the real world is. Does that does that
Sure.
does that help?
Yeah, it does answer my question, and I'm sure a lot of people who love monetizing the things that are already existing are also enjoying the session. And yeah, guys, I understand a few things here and there can be a little technical, but yeah, the recording is going to be there. So you can tune in again and, grasp it on your own pace. Now, moving ahead to the next question. So, um, again, integer factorization, which is the primary algorithm here. So my question is about that. Why is integer factorization crucial for cryptography, and how does factor n apply it in practice?
Sure. So the crucial part of the blockchain is actually the service that is on the blockchain, which is integer factorization as a service. And so I'll give an example, a couple of things that have happened. So in the past 15 years or so, there have been RSA systems that have been implemented to secure things. I'll give you an example. So Tesla secures part of their chain of communication from the key fob of the car to the car using RSA. Somewhere along the line, there's RSA somewhere. Banks used it, as I mentioned, and most notably in Estonia and in Slovakia in 2012, they implemented a national ID system that used identifications, digital IDs for their population that could sign information, so they could sign it, and also that could identify them in the official national systems for different things, right? Taxes and all sorts of legal documents. Now, the algorithm that protected all of this digital identification was RSA. Now, the algorithm itself, when used properly, is safe. The algorithm, when used properly, is safe. So, in 2012, they implemented this, and so about every year, they were rolling out hundreds of thousands of IDs as more and more citizens were being onboarded onto the national ID system, which was great. Now, that was in 2012. In 2017, 5 years later, thanks to research done at a university, it was discovered that the way in which the cryptographic keys for that national ID system for Slovakia and Estonia were created was not the best, was faulty. And so what that led to was the integer factorization of over 700,000 national IDs of real citizens. And so, one of the things that Factor N is really good at is if there is a country that wanted to implement a national ID using RSA, which is the most common one because it is safe and it is easy on the hardware. Notice that IDs don't have much hardware. And so, if you were a country and you were implementing a national ID, one of the ways in which you could audit how good your keys are is taking a subset of all of your keys and investing money by placing a reward on factor N to break those keys. And so, for example, if Estonia and Slovakia had done that in 2012 and they had invested, I don't know, $10 million and place a subset of their national IDs on the factoring blockchain for auditing, instead of learning 5 years later that their system was broken, they would have learned that 6 months, 12 months later, instead of 5 years later, when they had to undo everything And God knows how many of those identities were impersonated and how many things were signed by illegitimate users that were able to break that security and did not disclose it. So, the real value and the most valuable thing on the practical side of things for Factor N is its ability to place rewards on integers in a cryptographically safe manner integrated into the blockchain itself, where you can anonymously place a bounty on an integer, and you can as well anonymously claim the bounty for having factored that integer. And so I think this is the key value that the blockchain, my blockchain, Factor N, brings to the space, a real service on a real blockchain where the mining hardware can be used and is used to provide the service that the blockchain offers.
Tremendous. Well, I can only imagine how it would feel as a citizen to, realize that for 5 years straight, your identity was at risk, and maybe they were risked probably.
Yep.
Uh, yeah. So okay, so there's this thing called automatic difficulty here, right? So how does the automatic difficulty adjustment maintain the 30-minute target block time?
Yep. Right. So this is a property that applies to all proof of work blockchains. For example, Bitcoin's block time is 10 minutes. So their algorithm is tuned to adjust the difficulty to 10 minutes. And the way it works for Factor N it's the same way. The only difference is we have a target block time of 30 minutes instead of 10 minutes. This has to do with the difference in the algorithm because integer factorization requires a lot of time to set up polynomials, parameters, and some very complicated math to factor very large integers, I decided to make the block time longer for that reason because it's a little bit more complicated. And so I set instead of 10 minutes, 30 minutes, and then the algorithm is the exact same. If the average block time during an epoch is about usually it's about 2 weeks or 672 blocks for our blockchain. If in that period of time of one epoch, the average block time is higher than 30 minutes, then what we do is we reduce the difficulty. And then if the average time is much faster, 25 minutes, 20 minutes, what we do is we increase the difficulty. And so the idea is that if we are mining too fast, if our average time is very low, that means that our network is able to manage a higher difficulty level. And so it increases the difficulty level to try to get it to 30 minutes. And on the opposite side, if we're taking too long, if we're taking 35 minutes, 40 minutes, an hour, then what the algorithm does is it makes an adjustment and says, okay, this difficulty is too high because we are getting above 30 minutes. Let me lower it to try to get it closer to 30 minutes. And so the algorithm, what it does is essentially that. Originally, I only change the difficulty level at every adjustment by one digit. So we would add a digit longer to the integers that had to be factored, or we would remove a digit and make the integers smaller than had to be factored. We have learned through experience that that algorithm is too slow in adjusting things. So we recently, about 2 months ago or so, readjusted the algorithm to make the adjustments in bigger steps. And so now we adjust instead of at steps of one digit, we adjust in steps of 2 digits and 4 digits. One thing, this will get slightly technical for a moment, is that we now will be soon doing only even difficulty levels and we remove the odd difficulty levels. And this has to do with a distribution of brilliant numbers. And so essentially, the difference between the difficulty, for example, 500 digits and 501 digits. 501 digits is significantly harder. It's like 4 or 6 times harder, 501 than 500. And then 502 is a lot easier than 501. And so there's like some mathematical phenomenon going on there, which I will not explain. And so that's why we are changing to only even difficulties, because they're smoother, and the transition from one difficulty level to another, that difference in difficulty is very small. So the system is running smoother, and the load of work on miners is also much smaller from one difficulty to another, and so that will just benefit everyone. And so we implemented these changes. The miners already voted for it, and so it will become live in the blockchain very soon.
Awesome. Looking forward to it. When I was young, maths was not my strongest subject, but yeah, it does feel like I'm sitting with an expert, and I really see the passion here you have for, this technology. So yeah, appreciate it. Okay, moving ahead to the next one. So, okay, now coming to strong semi primes. So, what role do strong semi primes play in factor N block validation and network integrity?
Yes, so something I want to mention, the term strong semi-prime is a term that I made up because it describes what it is. But then a couple of my friends, mathematicians, talk to me and they're like, that's not a real term, right? You made that up. I'm like, yes. So let me explain a little bit. So a strong semi-prime, you can think of it as sort of the numbers that are used to create RSA keys that are safe, that sort of were properly created. So strong semi-primes, sort of RSA keys would be the standard. And so what does that mean? Well, that means a couple of things. The first one is that number is a brilliant number. Now, the term brilliant number is a proper term. If you Google it, you will learn a lot about brilliant numbers. Brilliant numbers are numbers that have the same number of digits in a given base. And so we talk in base 2 because computers use binary. So if you have a number that has two prime factors, for example, and then those prime factors have the same number of digits, then you have a brilliant number. So, for example, you have a number that is 10 digits, and then you have another number that is 10 digits, and you multiply them together to get a number of 20 digits. Then that number of 20 digits would be a brilliant number. Of course, both numbers of 10 digits have to be prime numbers. And so a strong semi-prime, it's simply a prime, a strong semi-prime is simply a number that has exactly two prime factors, and the prime factors have the same number of digits in them. And then if you wanted an RSA number, in addition to those conditions, then you would need several other strong conditions that have to do with security and randomness and a couple of mathematical properties, which I will not go into. And so a strong semi-prime, you can think of it, it's a number that has exactly two prime factors, and those two prime factors have exactly the same number of digits. And so why is this important? To find a solution in the mining of factor n, what you have to find is a strong semi-prime. You have to find a number that has exactly two prime factors, and those two prime factors have exactly the same size in the number of digits. And so if you are able to find that, then you submit that to the system, and the system validates that in fact those two numbers are prime, they have the same number of digits, and that they are within the parameters the blockchain gave you. And if that's true, then you have solved a block. Why is this important? The reason it has to be a brilliant number, the reason they both have to be prime and the same number of digits is because for RSA, that is the most basic condition. So for RSA keys, you have a number that protects a bank, and that number has exactly two prime factors, and they have the exact same number of digits in binary. And so that's why the mining algorithm it demands that, because it is what the RSA algorithms in the real world that use real cryptography to protect real data, to protect real IDs of, in countries actually use. Also, that configuration is the most difficult configuration to factor at any given size. Two numbers that have the two prime factors with the same number of digits is the case that is the hardest to factor, which is the reason why it's used to secure communications in LSL certificates and banks and so on. So that's why we use that for mining.
Awesome. Thanks, Jan, for answering in so much detail. And being on the marketing side of crypto, I don't really go in that deep in these things. But yeah, this is the perk of this job. You talk to people who have different kind of expertise, and I'm really loving how you have think through every problem here and how factor n is finding the solution to all these things. Okay, yeah, moving ahead. So there's another term we have here, dynamic supply model, right? Uh, so how does the dynamic supply model balance minor rewards while avoiding excessive inflation?
Yes, I think this is a very important topic to speak about because the cryptocurrency community at large, people from Bitcoin, Ethereum, and just the community, regardless of what project you come from, there is a traditional way of thinking about this, and the way we do it is very different. And so it's very important that we speak to the community and educate them on a couple of things that are, or so far, have not been very common. So the first thing is the factor in blockchain has a model that is based on the following philosophy. If you work more, you get paid more. So the reward function for factor n, as the difficulty increases, the reward also increases. It does so very, very slowly. And so that is to dampen inflation. So that's on one side. So we have a force that is sort of pushing the supply upwards, higher. And so to give you an idea of how fast the difficulty increases, the original difficulty was 230 digits. So now you had to factor 230 digits to find a brilliant number to solve a block. Right now, that difficulty is around 460 digits. So we have a little more than doubled the number of digits for mining. I want to make an observation here. Well, that's too technical. Let's leave that for later. Okay, so that's on the number of digits. Okay, now the original supply, I think we gave around a coin per block. Right now, at the current difficulty, we're giving around 16, 17 coins per block. And so the difficulty level from 230 to 460, you know, one question you can ask is how much more difficult is it to factor a 460 digit number compared to a 230 digit number? And so I will give you that difference in time rather than some math formula, which is you can factor a 230 digit number in less than a second using your cell phone. There's a way to do that. To factor a 460 digit number on your cell phone will probably take a day or two, right? So you go from less than a second to more than a day if you were to use a phone to measure the difference in difficulty. So the difficulty is exponentially higher. It's like thousands of times more difficult if you think about it in those terms. Okay, so it is much more difficult, so you get paid 17 coins instead of one. That's on one side. Now, there is another force in the blockchain that pushes the supply downwards and makes it shrink rather than grow. And that is every time you place a bounty on an integer to audit some RSA key, to claim that bounty, the person claiming it has to burn coins. I think right now it's 0.01 fat coins. And so the more the integer factorization service gets used, the higher the burn amount of coins in the system. And so the more utility we have, and the more the utility gets exercised and used, then the more the supply shrinks. And so I can think of a day when per block the net change will be negative rather than positive because the volume of RSA keys that are we are being asked to audit is so high that the amount of coins we would have to burn per block is higher than the amount of coins that are given to miners as a reward. And so in factor N, instead of having fixed cap supplies, instead of pretending that I know what is best, I simply created a system with two market forces that will fight themselves to balance what the supply should be. And so I'll give you an example to sort of ground all of this. We launched in April 20th, 2022. We are now September 4th, 2025. So it's been 3 years and say, I don't know, 6 months, something like that. So in that amount of time, the supply, the coin supply of the factoring project is less than 1.1 million coins. That is to say, in about 3.5 years, our coin supply is smaller than 10% of the supply of Bitcoin. Bitcoin right now is at, I don't know, 19 million, 20 million. We are 3.5 years into it mining. We are at 1.1 million. And so the people who are concerned about inflation, it's like our inflation rate is very small. The speed at which the supply grows is extremely small. And it is true that we do not have a cap on the coin supply, but that's because we don't need to. First of all, it grows very slowly. And second of all, there is a force of utility that burns coins and shrinks the supply. And so those two forces balance each other out. So that is very important to know.
Interesting. Well, I see, the concept we have here is very important for the entire crypto space, but yeah, I wonder if there are like a handful of people who are considering about this. So yeah, factor N definitely needs to reach the masses. Okay, so moving ahead to the next one. So why was the factor N designed with no pre-mining, no pre-sale, and no governance allocations?
Well, the idea was sort of very similar to Bitcoin. I it to me personally, it's a matter of trust. I tend to trust projects that have no pre-mine, no pre-sale, and the idea is that when you launch fairly and you give everybody a chance to mine the project, and you don't sort of create coins and keep them for yourself, it's a matter of fairness. I think that's the best way to do it. Um, and I've seen projects where The team, the founders, they keep like 90%, 80%, like over 50% of the coins. And there is a to me personally, there's some level of distrust there, of why on earth will you keep that amount? Um, but that's why essentially it's a fairness thing for me.
Yeah, that's a red flag actually. Like it does seem like, you're building for the VCs and the core team instead of the community. So yeah, appreciate it. All right. So okay, research is gonna be a crucial part here, is right. So how does factor in incentivize research in, maybe number theory, computer science, and quantum computing?
Yes. This is for the researchers. There's a couple of things. The first thing is that there are several areas of research that depend quite a lot on factoring integers. And in fact, there are over 12 such projects that depend on factoring integers. Um, there's a couple of search research programs that they're searching for very specific things, and then there's some sort of discovery type programs that through factorizations they want to find out a couple of things. So there is that. Now, something that's sort of very important as well is that because integer factorization is such an active area of research, and actually about 4 years ago there was a paper published that in the deterministic category of algorithms for integer factorization, a breakthrough was found, and this work was done at the University of Australia, um, where they got an algorithm that had a complexity, sort of a word complexity of 1/5 of a degree. So the fifth root of n as n grows. And so, for the folks who understand this language, and so just to give you an idea of how recent there was a breakthrough in integer factorization just 4 years ago. And so there's a lot of active research going on that can be advanced through this for several reasons. And so one of them is that improvement, for example, in that algorithm that was done 4 years ago, is something that could be implemented to mine the project. And so you can use the advancements in research in integer factorization that academia produces to improve the mining of the project, which would then increase the security of the project and would also monetize research discoveries. And so, one of the things that I imagine is that one day universities in the US, the math department will get together with the computer science department to talk to hedge funds to make business, where the hedge funds would buy the hardware, the computer science department would run the mining software and implement improvements, and the mathematical department would improve the theoretical side of integer factorization. And so you would have a win-win-win situations where computer science departments would improve algorithms and would have a lot of hardware to play with. The mathematics department would get funding for the research through their own research. And so the more improvement they found, the more efficient their mining gets, the more profitable the mining is. And so the math department, the computer science department would benefit from that. And then the hedge funds would be profitable. And so this is sort of a team of unlikely characters, mathematicians, computer scientists, and hedge fund managers that will be able to come together to secure the network, provide a service of RSA key audits where everybody would benefit. The hedge fund folks care about a profit, they get their money. The mathematics folks care about funding, they get their funding, but they also care about research and producing new results, and so they get to do that. And the computer scientists the same. And so, ideally, I think we would come to a point where those three unlikely characters would come together to work on this.
Well, this was probably the favorite part of, any VCs tuning in or any researchers tuning in for the during the entire session. Okay. Yeah, so I really like the idea, but I don't fit in any of the categories that you mentioned. But yeah, I'm here as the cheerleader. All right.
Thank you.
Absolutely. Yeah. So, in what ways does factor and act as a real world measure of encryption security? Because you're so passionate about this. I'm really sure it's not just limited to the Web3 space.
Yes, well, the RSA challenge list that I mentioned earlier is the barometer today of the level of security for RSA and for integer factorization. The world record is 829 digits. Um, and so, right now, the best we have done in the blockchain is about 700 and a couple of digits. And so, as the blockchain improves, as we gain adoption, as the community grows, and more computational power, as well as academic power comes into the network, what will happen is that we will be able to factor integers that break the world record. And so we will then replace the RSA challenge as the barometer for security and integer factorization. And so that's how we would have a live record of how good are we on the planet as human beings, how good are we factoring integers. So the blockchain is sort of a live record of that instead of having a fixed list where the record is 829, but I think the next one is like 890 digits or something. There is a gap there of like 60 digits. And so, if somebody factors an 840 digit number or 850, how can you probably certifiably verify that indeed that is a world record, that there wasn't some gimmick going on? Whereas in the factoring project, because it is a live network and we would be auditing our RSA keys and our mining uses this, it's sort of a much stronger case for proof and for reference that the work that we do is in fact verifiable and can be trusted to indicate how well we can factor.
Got it. Well, yeah, one of the biggest achievements is, having Coinbase on board. So, like, I mean, winning the competition, but yeah, Coinbase is your cheerleader now. So, how did winning the Coinbase crypto community fund grant support factor ends development?
When I wrote to them, they they sent me an email back. A couple of their engineers had some questions, so they sent me a few written questions. And then when we met and we talked, they had a couple of more questions about this. And so they were intrigued by the proposal, and so they gave me $100,000. I mean, at the time, the project did not even exist, right? They paid me to figure out if it was even possible to create a blockchain with integer factorization, because at the time, it wasn't so clear that you could do that. And so $100,000 were given to me, and they were paid out every month. And so about 4 6 months in, I was able to do the work, write the white paper, publish the code, and start the blockchain. And the last payment they made was in summer, and it was for the remaining full amount because I had already created the blockchain and written the white paper. And so they sort of got ahead of things there. Or I got ahead, and they were kind enough to pay it all when I was done. And so that was tremendous. I mean, if I had not received that funding, I'm not so sure that I would have been able to dedicate myself sort of full time to think about how to solve this problem.
That's actually the beauty of this space, right? So the builder spirit here is just amazing. All right. So, okay, let's come to the challenges that miners face. So, my question to you is, what challenges do miners face as factoring complexity and sieving difficulty increase over time?
So the algorithm which we have right now, which is about to be phased out in a week or so, changed the difficulty level very slowly. And so when there was a drastic change in computer power in the network would not adjust fast enough. And so that's something that we have already fixed. And so this algorithm that will be coming in now, that will activate in about a week or so, is going to fix that. So the speed at which we update the difficulty level will be much more, what's the word? Sensitive to the change in the network. So it will change faster and adjust faster to the actual power of the network. So that's on one side. And then on another, we are eliminating the odd difficulty levels because there's a big difference between even and odd. And so to make it a smoother transition across difficulty levels when we update, we are removing the odd difficulty levels and only keeping in the even ones to make a smoother transition every time we jump to a new difficulty level. So those two things are coming in, and I think those two things will be enough to address any hardships that the previous system and update difficulty algorithm had.
Right. Okay. Uh, a question I personally have, like, how many people do you have in team? Like, how many people does it take to solve such a big problem, or let's say bring such a disruptive solution in the space?
Are you talking about how much equipment, how many people does it take to factor a block? What's the question?
No, actually, like, how many people are there, building factor in?
So well, on Discord, I think we have about a little over 3,000 folks who follow us there. We have our sort of our discussions there. On Twitter, we have about, I don't know, a little over 9K. And so our community, I would say, is around 12,000, 13,000 people. On the mining side, we have miners, a lot of miners in Europe. We have some in Asia. And yeah, in Latin America, one of the things that I want to do is sort of start to um, introduce ourselves in Latin America. I mean, I speak Spanish, and sort of my family is also from Latin America. So I do want to start sort of educating and talking about this in the Spanish spaces. In English-based spaces, it's sort of a little bit easier. Like for example, this MMA that we are hosting today, and there's sort of a lot of resources available in the English-speaking world, and of course, I will be using those. And anybody who would like to have me on for an MMA, I'm open. Just shoot me a message, and but yeah, that's around the size of the community.
Right. And how many people are on the team? Like, who is building alongside you? Whose baby is factor
Oh, I
in?
see.
Yeah.
So we are. How many are we? Oh, let's see. We are one, two, three, four, five. I would say we are about seven, eight folks. So it's me. Now we have Rover Media, who's helping us with the rebranding, and clear messaging. And we have our mining ambassador, Alex from Germany. He's the one who built the mining pool, and sort of all stuff related to mining. He's the expert on that. We have a couple of folks. We have a gentleman from Africa who helps us moderate and run Discord. We have a couple of folks from Germany and Switzerland that also help us run the community and help us with gathering sort of the opinion of folks, if you will. And then we have a gentleman from Argentina who helps us with some of the Spanish content, if you will. So we have me, we have Alex, we have Robert Media, we have two folks from Germany, one folks from Switzerland, one person from Africa. Oh yes, we also have somebody else who's very important. on the technical side who helps us with the website and running some things. So he would be the eighth person. Am I leaving anybody out? On the team, building, managing things, and keeping the project together, we have eight folks, including myself.
Awesome. Like, I was just curious, the mission you have is is huge. So just wanted to know, how many people are there supporting you along with the journey. All right.
Yep.
So yeah, so far so good. I loved how you answered every question, and I really appreciate how you used examples to explain to the audience. And okay, so one more question before we reach the
Sure.
end of the session. So how can researchers, developers, and the wider community get involved with the Factor N's ecosystem?
Yes, sure. The first thing you can do is join our X page. Please join us. All of our updates will be posted here. Also, you can join Discord. You can find the link to our Discord on our X page, which is just Factor N at this moment. Note that Factor is written with a zero. So it's Factor N where the O is a zero. With the rebranding that will be coming soon, we will sort of update everything. You can find us on Google. Just type in Factor and you will find us. So join our Twitter page, join our Discord, and we can sort of take it from there. If you're interested in mining, you can go to our GitHub page, just Factor N, the project. You can find all the open source software there. And if you have any questions about anything, you can start join our Discord and ask things there, and we'll be very happy to address any questions.
Absolutely. Everyone, I hope you found the session useful. And yeah, Johan, we're looking forward to, the revolution you're going to bring with Factor N, or you're already bringing in with Factor N. So yeah, before we conclude the session, would you like to say anything else? Maybe we left something, or a closing remark for the community?
Yeah. First of all, thank you for tuning in. We will be rebranding soon, and our messaging, the way we communicate the value that we bring to our community and to the crypto community at large, we'll be communicating all of this sort of in a clearer, concise way, so that we are able to communicate properly to everybody. People who want to mine, the researchers. The financial folks, the hedge fund managers, because our audience is so broad and their interests are so different. This is something that I've just learned sort of recently, if you will. I want to make sure that the right message gets to the right community, because something that a hedge fund manager really cares about might not be the same thing that a researcher, academic might care about. And so we are working really hard right now to sort of get the right information to the right community, so that they're able to see what's in it for them in our project. And so we are working very hard on this. And in about a week or two, we will be starting that work of communicating better, so that we are able to help people understand the value that we are able to bring to the work that they do and to the business they're in. And so stay tuned for that.
Absolutely. Well, all right, everyone. That wraps up our today's AMA with Yuan. And yeah, it was actually an interesting one for me as well. Um, so we have learned how factor n is turning complex mathematical problems like integer factorization into a breakthrough consensus mechanism. So yeah, like doing this while also supporting cutting edge research and advancing blockchain security. So absolutely, big thanks to you, Yuan, for sharing all those insights, for providing us examples, And thank you to our community for joining us today. Guys, don't forget to follow Factor N and stay updated on their journey as they continue to, push boundaries of blockchain and cryptography. So, yeah, guys, this has been Titanium Talks AMA. Until next time, stay curious and keep building the future.
Thank you.
Bye bye, everyone.